Hello friends, this is Gangadhar from Maths Ganga. This is a problem asked in JEE Advanced 2018 from the concept functional equation involved with the differentiation of that functional equation. See, f is given as a differentiable function with a constraint on that as f of 0 is equals to 1. And also they have a functional relation f of x plus y is equals to f of x into f dash of y plus f dash of x into f of y for all real values of x comma y. Then we need to find the value of log f of x to the base e. See, there are different ways to solve this problem. One approach is along with the functional relation, identifying the function which satisfies the given functional relation. And the other thing is usual integration process. For suppose, here it is given as f of x plus y is equals to f of x into f dash of y plus f dash of x into f of y. See, this is f of x plus y and here we have a plus sign. So immediately we all think that by imagining the function as sine of x plus y, and we know that sine of x plus y is sine x cos y plus cos x sine y. If the function f of x is sine x, then f of x plus y is sine of x plus y, f of x is sine x, f of y, if f of x is sine x, then f of y is sine y and its derivative is cos y, and its derivative is cos y, right? And then f dash of x, derivative of f of x as cos x and f of y as sine y. So surely f of x is equals to sine x satisfies the given functional relation. But f of 0 is sine 0, which is 0, but it is given as f of 1. So f of x is equals to sine x, even it's satisfying the functional relation, but that sine x is not the required function here. So what we need to do? We need to identify the function which is satisfying the functional relation. That in the sense, we need to search for another function. And already we know, we are aware in different situations that the function satisfying the functional relation f of x plus y is equals to f of x into f of y is usually of the form a power x. A power x, the function which is satisfying this functional relation. With that idea, I am going to try with the function f of x is equals to a power x. Suppose if you let that f of x is equals to a power x, then check with this functional relation. So what is f of x plus y? Is nothing but a power of x plus y, and f of x is a power x, f dash of y, f of x is a power x, f of y is a power y, and its derivative is a power y into log a to the base e, plus f dash of x, derivative of a power x is a power x into log a to the base e, and f of y is a power y. And if you observe the right side, again you are able to pick out a power x plus y, a power x into y, a power x into y of log a base e. See, there are two terms, a power x plus y log a base e, a power x plus y log a base e, so two times of this one. And if you cancel out that a power x plus y, we have that log a base e is equals to 1 by 2. And finally, what is a? A is e power 1 by 2. So if you replace e power 1 by 2 in this function, this is nothing but e power 1 by 2 power x, which is equals to e power x by 2. Now e power x by 2 is the function which clearly satisfies the given functional relation as well as the given condition. What is the condition? F of 0 is equals to 1. Since f of 0 is equals to 1, e power 0 by 2 is also 1. So our required function satisfying the given relations is nothing but e power x by 2. And what we need to identify? We need to identify log f of x to the base e. Okay, so log f of x to the base e is nothing but logarithm of e power x by 2 base e, and just drag that x by 2 out. So x by 2 of log e to the base e, and your answer is x by 2. So this is the problem solved by using the functional relation. Okay, without knowing the function, without identifying the function satisfying this functional relation as a power x, also we will try to prove it. Okay, in other way, now I am going to do the other way of solving this one. First, suppose we have that f of x plus y is equals to f of x into f dash of y plus f dash of x into f of y, and it is given as f of 0 is equals to 1. Now what I am suggesting you is take x is equals to y is equals to 0. If you replace x and y as 0, we have that f of 0 is equals to 0 plus 0 is equals to f of 0 into f dash of 0 plus f dash of 0 into f of 0 by replacing both x and y with 0, and this is f of 0 is equals to 2f of 0 into f dash of 0. Here we have two terms, but it is mentioned that f of 0 as 1, so replace 1, so 2 into f dash of 0. So what I have, f dash of 0 is equals to 1 by 2. So along with f of 0 as 1, we also have that f dash of 0 as 1 by 2. So f dash of 0 is equals to 1 by 2. Now do one thing. Take only 0 in the place of y. Now take y is equals to 0. If you take only 0 in the place of y, now the given functional relation will become that f of x plus 0 is equals to f of x into f dash of 0 plus f dash of x into f of 0 by replacing y with 0. This is f of x, and this is equals to f of x into f dash of 0 is 1 by 2 plus f dash of x into f dash of x into f of 0, which is nothing but 1. Now this is f of x by 2, this is fx. So if you simplify it, we have that f of x by 2 is equals to f dash of x. With the given relations, I have a linear equation in terms of linear differential equation in terms of f of x. What it is, f of x by 2 is equals to f dash of x. Now if I rearrange it, what I have? If I rearrange it, I have that 1 by f of x into f dash of x is equals to 1 by f of x into f dash of x is equals to 1 by 2. Okay, now if you integrate it on both sides with respect to x, if you integrate with respect to x on both sides, this left side will become that log f of x to the base e, whereas this right side is nothing but x by 2 plus some c. So f of x is nothing but e power x by 2 plus c. Since f of 0 is given as 1, by replacing x with 0 to get 1, you have that, you will get that c as 0. So finally you have f of x is equals to e power x by 2. And since f of x is e power x by 2, log f of x to the base e is again x by 2. So this is another way of solving the given problem without identifying the function satisfied by the functional relation. So this is a problem involved asked in JEE Advanced 2018 on the differentiation of a functional relation. Thank you.